Students in a statistics class took their second test. The following are the scores they earned. Fill in the stem and leaf plot below. Use the tens place as the stem and the ones place as the leaf. Describe the shape of the distribution. Complete the stem and leaf plot below. Enter each row of leaves as a set of numbers separated by commas. Use the tens place as your separation between your stem and leaves. Okay, so we just need to go through this data set and identify first what the maximum and minimum values are. So to me, I see 93. I think that might be, nope, there's a 98. So that's probably the largest. Okay, and then the smallest, I see 50. Is there anything smaller than 50? It doesn't look like it. Okay, so what that means is, since my stems are tens place values, I need to write in my stems as 5, 6, 7, 8, and 9. So those are all the different stems that I'm going to have to go through all the tens places that are possible. Now I just need to go through and write in my leaves. Now, it would be great if this data set was sorted, and it doesn't happen to be, so tell you what I'll do. I'll start putting things in the stems and leaves first. So 93, that would be a leaf of 3 in the group 9. 69 has a stem of 6 and a leaf of 9. 70 has a stem of 7 and a leaf of 0. Then 74, 73, and I'm just putting this off to the right to make notes, and then I'm going to finish up my stem and leaf plot afterward. 288. All right, and I think you get an idea of how this is done, so I'm going to pause and finish up so you're not watching through the whole thing here. Okay, so I have sorted everything into the leaves here. Now what I'm going to do next is take each set of numbers here, and it isn't always necessary. It's really up to your instructor, and so you might want to inquire as to what they expect. But what I'm going to do next is I'm going to sort the data within each stem and then present my final stem and leaf plot in that manner. So let's see, I've got these two zeros, so 0 and 0 is my leaves. Then I've got 1, 2, 3, 4, 5 ones. And a 2. I'm starting to run out of space here. Then I have a 7 and a 9, so I'm going to have to... Oh, look at that, I have another 2. And then a 7, and then a 9. All right, so that takes care of that set. So going down to the stem of 6, I have a 0, then 2 ones, and you try and keep these vertically arranged here so you can tell the distribution of the data in the end. Let's see, then 6 looks like the next, then 7, 8, 9, 9. So 7, 8, 9, 9. All right, I think what I'll do is I'll erase all the ones previous so that it looks a little bit nicer. All right, now here I have 0, 1, 3, 4, 5. Then 1, 5, 7, 8, and 3, 8. And there's my sorted stem and leaf plot. The only thing that you need to make sure you give in the end is a key indicating how the stem and leaf plot is read back. So we'll say here, it doesn't matter which value you choose. About 6 with a bar and then 1 is equal to 61. And now we could read back the data set from the stem and leaf plot. All right, so what shape is the stem and leaf plot above? So in order to determine the shape, so that's the distribution type, think of each of these stems as a histogram bar. Now this would be a histogram bar that is oriented differently. It's going to left and right instead of up and down. But think of that as a histogram bar and then trying to decide what type of distribution you might have. So if we reoriented it so it was going the other direction, so 5, 6, 7, 8, 9. So we have a really tall bar here, and then we have a little bit shorter bar, then a little bit shorter, a little bit shorter, a little bit shorter. All right, so what would fit that best is we've got a big clump of our data over here to the left-hand side, and then we have this elongated tail, and that's to the right. So this data would be skewed to the right. We define the skewness where the elongated tail